Share screen mo na, ano, Pedroso. Share screen.
You have picked up the gloves. Pick up the conical flask and place it on the heating plate. You have picked up the conical flask 250 milliliter. You have placed the conical flask 250 milliliter. Transfer the contents of the weighing dish to the conical flask. You have transferred the content of the You have placed the weighing dish. Use the measuring cylinder to transfer 50 milliliter of demineralized water to the conical flask. Slide up the lab pad for more info. You have picked up the 500 milliliter bottle. You have transferred the demineralized water into the measuring cylinder. You have placed the 500 milliliter bottle. You have picked up the 100 milliliter measuring cylinder. You have put the demineralized water into the conical flask. Place a magnet in the conical flask and turn on the heating plate.
Magnet.
You have
Enter
picked up the You have placed the magnetic stirrer. Please press the start button.
Start mo yung yan.
You've dissolved the unknown chemical in the water. Dispose of your gloves. You have disposed your gloves. Why is it important to use demineralized water? Lab pad up.
Why is it important to use? A. Because the minerals water poses less. Wait lang. Wait lang.
Again. Check out the Theory tab on your lab pad if you don't know the answer. Chemicals. One example of a This is incorrect. Please. Why is it
Try
That's
mo,
right.
D.
Reg contained in it. While we wait for the sample of unlabeled chemical to dissolve, let us find out how much silver nitrate we should add. In a gravimetric analysis, we want to precipitate the ions we are analyzing for as an insoluble salt so that we can weigh them. Lab pad down.
Continue mo.
The general reaction states that 1 mole of unknown chloride, XCl2, reacts with 2 moles of silver nitrate to create 1 mole of unknown nitrate, X2 times NO3, with 2 moles of silver chloride. Yes, spot on. We should add more silver ions than chloride ions. When the silver ions are in excess, we can be sure that all the chloride ions have reacted. The general equation states that 1 mole of unknown chloride reacts with 2 moles of silver nitrate, giving 1 mole of 2 moles of silver chloride. Alkaline earth metal chloride. Click View Image button to see the image.
AgNO3. Ay,
Ito ba yun?
hindi, AgNO3 as XC12. Yan. XSL12. 2. Gagabi.
Yes, you are right. You can see from the balanced chemical equation that 1 molecule of unknown chloride reacts with 2 molecules of silver nitrate, so you should have twice as many molecules of silver nitrate. Now you can find the number of moles of silver nitrate to use by multiplying the number of moles of beryllium, magnesium and calcium chloride by 2. Fill in those numbers in your lab journal. Lab pad down. Click the yellow field in the lab journal to calculate the number of moles of silver nitrate to use in each of the 3 cases. You've calculated and put in the lab journal the number of moles of silver nitrate for beryllium chloride. It equals 0.076 moles. You are in the magnesium tab. You've calculated and put in the lab journal the number of moles of silver nitrate for magnesium chloride. It equals 0.064 moles. For beryllium chloride, 0.076 moles of silver nitrate are used. For magnesium chloride, 0.064 moles of silver nitrate are used. For calcium chloride, 0.055 moles of silver nitrate are used. How many moles of silver nitrate should we use to be sure that we have excess, no matter which of the 3 compounds it is? That's right. Even though 0.075 moles would be enough to ensure excess if the unknown compound is calcium or the silver nitrate has already been dissolved in water with a